Hey, welcome back to your favorite pre-calc class. Let's take a look at solving quadratics, right? So the standard form of a quadratic is that ax squared, notice the power is 2, right? Ax squared plus bx plus c. So a can't be 0, otherwise it would clear out that x squared term, right? So we'll look at a couple different ways of solving quadratics. The first way is to solve it by factoring on this first example. And we know if a times b equals 0, if a is 0, statement would be true because we have 0 times b, or if b is 0, statement would be true. So if you have x plus 4, if you have two things being multiplied, x plus 4 could be 0, or 3x minus 7 could be 0. We subtract 4, so we got negative 4 could be an answer, and we've got 7/3 could also be an answer to this quadratic. That's using the zero product property. So that's factoring by solving. Let's do it by factoring out and finding all the roots, right? Roots, zeros, x-intercepts. If you had this x cubed minus 25x, those are all the same thing on a graph. Let's find these roots or x-intercepts or zeros if this function is y equals x cubed minus 25x. So let's factor out an x. Notice they both have an x. And let's factor that x squared minus 25, right? That's difference of squares there. We've got an x and an x. So that'd be a minus 5 plus 5. Of course, you could check that. X squared plus 5x minus 25, that's 0, right? So that would be x squared minus 25. And then we're going to use that zero product property. If a times b times c equals 0, then a could be 0, b could be 0, or c could be 0. So we're going to go ahead and take each factor, set it equals 0, and solve. So we got negative 5, add 5, both sides. Here we got 5, and we got 0. So 0, negative 5, and 5. So the solution is negative 5, 0, and 5. Or here's our solution, another way to write that solution set. Okay? If we're solving this next one by factoring, or in other words, finding our roots on this, make sure you get one side equal to 0 first. Notice here I do not have one side equal to 0, so let's take that over before I start factoring. And then I say, well, what can I factor out? I could take 4 and an x out of each of those. And so then take each of those factors, set it equals 0. So we got 0, add 6, and 6. 0 and 6. You guys go ahead and try that next one. All right, check yourself on that. Should have got negative 3, 0, and 3. All right, here you're looking at this. Hopefully you notice that you got to get one side equal to 0 on this. So I'm going to FOIL that and then subtract 6. So I got x squared plus 4x plus 3x plus 12, then minus the 6 equaling 0. Again, I got to have one side equal to 0. And then I'm right here, and then I'm going to have to factor it to solve it, right? So I'm going to, I'm looking at that x squared, so I got x and x. Look at that first term, right? I like the backwards FOIL. That's how I like to factor. Now I'm looking at that 6. I'm like, well, I gotta use factors of 6. Am I going to use 2 and 3, or 1 and 6? Yeah, hopefully you're thinking, let me try 1 and 6. And it's a positive 6. So I know when I do my first outer inner last, when I multiply the last terms, it's got to give me a positive 6. So it's going to either be a positive times a positive 1, positive 6, or a negative times a negative. So we're going to try positive times a positive, and then double check it. Make sure that's the right factorization. That is a positive 7x in the middle. So I did factor it correctly, right? So I'm like, okay, looks like I factored that correctly. And let's go ahead and take each factor equals 0, and then we're all done. So we got negative 1 and negative 6 on that. Now this next one, this is also a factoring. You can solve this by factoring. Anytime I see 1, 2, 3, 4 terms, I'm thinking, I bet you I'm going to be factoring by grouping. And if I'm factoring by grouping, I'm looking at the first two terms, two highest terms degree-wise, and saying, well, what can I factor out of both of those, x cubed and x squared? I can take a maximum of x squared out. Now, let me look at the next two, and what number can I factor out of those? What's their greatest common factor? Hopefully, I mean, probably tough to recognize, but 121 does go into that. 121 does go into 1331 divided by 121 is 11. And when you're factoring by grouping, the giveaways, you're trying to, hoping that they'll have a common factor between those two, right? So again, I'm left with, I got two terms here now. I got two terms. They both have an x plus 11. So I'm going to factor out that x plus 11 out front. And what am I left with? The x squared minus the 121. I'm factoring out the entire x plus 11 from each of those. You know, it's kind of like x squared times a minus 121a. If I take an a out, I'm left with x squared minus 121. Our a here is x plus 11. And then we go ahead, we set that equals 0. And then this does actually keep factoring. I have x plus 11. This is difference of squares. X minus 11, x plus 11. Set each of those equal to 0. So I got negative 11, 11, and another negative 11. So 11 and negative 11, I don't need to repeat negative 11 twice. Both of those are our solutions to this. Why don't you guys try it? Go ahead, pause the video and try that next one. It's also 4 terms. Solve it by grouping. Sure, you got negative 12 and 12 on that. So let's go ahead and factor this next one, see if it factors. Again, I'm looking at x squared. That'd be x and x, right? Then I'm looking at factors of 24. So I could go like 1 and 24. Of course, one of them's got to be positive, one's got to be negative. To give you, remember, first outer inner last, right? The last one's got to multiply, so one's got to be positive, one's got to be negative. I could have 2 and 12. Again, one's got to be positive, one's got to be negative, or vice versa. All right, 3, 8, 4, 6. So I've got lots of options here, but one's got to be positive, one's got to be negative. So their difference has to be 10. So which one of those am I going to pick? And then let's check it. Yeah, so we'll go x squared plus 12x minus 2x minus 24. Let's see, is that it? There's that 10x in the middle, positive 10x in the middle, right? So we're like, okay, we factored it correctly, set each one equals 0. So we got 2, negative 12. So here's another one, 6x squared minus x minus 12. I don't do that. Working backwards, FOIL this. So I'm looking at 6x squared. So I could go 6x and 1x. In fact, let me write this out. I could go 6x and 1x. Or the other option I could do is like a 3x and a 2x, right? So I'm going to have a few different options here on this one. And then I'm looking at factors of 12. You know, factors of 12, I'm going to have one, and one's positive, one's negative. So I could go like 1 and 12. I could go 2 and 6. I could go 3 and 4. And I could go vice versa on that. I could go 6, 2, 4, 3, and so on, right? So let's go ahead and do it. In fact, let's do it over here with this 3x and the 2x. We'll try that first. And hopefully you kind of try a few and you start thinking to yourself of what's going to work. Like let's try like 2 and 6. And let's try that. Let's have 6x squared minus 18x plus 4x minus 12. Okay, that's a minus 14x in the middle. That's not it. I need a minus 1x in the middle. So that's not going to work. So I'm like, forget 2 and 6. 6 and 2 would make it even worse. I could try that as well. Let's go with about 3 and 4. Minus 12x plus 6x minus 12. Well, I got a minus 6x in the middle. Get a little closer there. How about we switch them then? Plus 3 minus 4. And that's kind of how I'm thinking about this. I check that one, and I'm like, oh, 6x squared minus 12x plus 6x minus 12. There's the minus. Hold on, 4 and 3. I'm sorry, I did the same one, didn't I? Sorry about that. 4 and 3. There we go. 6x squared minus 9x plus 8x minus 12. There's the minus 1x. Okay, so we finally factored the stupid thing. Now I'm looking at it, and I can say, let's solve each of those, say it equals 0. Add 3. 2x equals 3 divided by 2. Okay, so we got 3 halves for one of our solutions. And I've got negative 4 thirds for our other. So a little bit tedious on some of those. But that's how I like to think about it. I don't like to do anything else, so sorry about those. Let's go ahead and solve that. X times 2x minus 19 equals negative 35. So let's get one side equal to 0 first. So we got 2x squared minus 19x. Let's add 35 plus 35 equals 0. And then we know one's got to be 2x, one's got to be x from the 2x squared term. And then I'm looking at the 35, and I'm like, well, 1 and 35 is not looking very likely, nor is 35. Well, it's got to be positive or negative. So I'm going to try, how about 5 and 7? Again, one's got to be positive. It's either got to be positive or negative. And I'm seeing the negative 19x in the middle, so I'm going to guess that. Let's see if that works. 2x squared minus 14x minus 5x plus 35 equals 0. That's it. Okay, we got lucky. Factored that correctly. So let's set each one equal to 0. So I got 7, add 5, divide by 2, divide by 2. So 5 halves and 7. Go ahead and solve that x times quantity x minus 13 plus 36. We'll check it. Just a second if you want to pause the video. Go ahead and check yourself with the in there and pause that if you need that work for a minute before we get into the square root method. So with the square root method, what we're doing is we're trying to get one side has to have a perfect square, and the other side is our number. So we're trying to get it in this form, like for example, x squared equals 25, right? So that we can just square root both sides. We square root both sides, and don't forget that's a plus or a minus, because not only is 5 squared 25, but negative 5 quantity squared is also 25. So I have two solutions, right? When I square root both sides, don't forget your plus minus on that. So let's do that with this using that square root method. We got x squared minus 36 equals 0. I've got that perfect square. X squared is a perfect square. Let me add 36 to both sides. Now I've got the perfect square equaling the 36 over there. I'm going to square root both sides. Don't forget plus or minus on that. So 6 and negative 6 would satisfy that. That's how we're using the square root method. Our first method, of course, we were factoring to solve, right? All that stuff we were factoring and using the zero product property. Now we're using the square root method. Here I've got a perfect square, x squared. So I'm going to subtract 7 on both sides. So I got 4x squared equals 44 on that. I'm going to go ahead and divide by 4. So I got x squared equaling 11. I'm going to square root both sides. So I got plus or minus the square root of 11 on that. This time my perfect square is the 3x minus 2, right? The 3x minus 2 is quantity squared. That's perfectly squared. So, and I've got the number on the other side, so we could go ahead and just undo the square. So let's square root both sides. 3x minus 2 equals plus or minus. I take the square root of 4, which is 2. So now I got two solutions here. I got to finish this though. I got 3x minus 2 could be positive 2, or I have 3x minus 2 could be the negative 2. So I'm going to have to solve those separately. So let's add 2 to both sides. So I got the 3x being 4, dividing by 3. So 4/3 for that one. Over here I got 3x being 0. I divide by 3. 0 divided by anything is 0. So I end up with 0 and 4/3 on that one. This one below it, I've got 2 times that perfect square, x plus 7 squared being 56. So I want to get rid of the 2 first, right? 2 is being multiplied by it. So let's undo it. So I've got x plus 7 quantity squared equals 28. And now I've got the perfect square equaling the whatever on the right hand side. So we're going to go ahead and square root that. So that'll undo it. X plus 7 equals plus or minus the square root of 28. And I should simplify that. 28 is 4 times 7. I know the square root of 4 is 2. So if x plus 7 equals plus or minus 2 root 7. So if x plus 7 equals the positive 2 root 7, x plus 7 could be the negative 2 root 7. And let's subtract 7 on both sides. So I have negative 7 plus the 2 root 7, and I have negative 7 minus the 2 root 7. So I guess if you want to, you could also just do it this way, where you have negative 7 plus or minus 2 root 7. So just make sure you recognize there are two separate solutions. You can't combine those, those are not like radicals there. Alright guys, go ahead and pause the video, try that next problem there. Make sure you got your correct work on that. Should end up with that negative 4 and 10. So we've done factoring to solve, where we use the zero product property, set each factor equals 0, solve it, right? Then we did the square root method, where we had to have a perfect square. This is called the completing the square method. We're also trying to use the square root method. So what we're trying to do is we're trying to get a perfect square by completing the square and then using the square root method. Okay, so for this one, if you notice, this does not factor cleanly, right? Like x minus 1, x minus 7, that doesn't work. X plus 1, x plus 7 doesn't work, right? So it doesn't factor cleanly. So what you do when you complete the square, right, this thing does not factor cleanly, is I'm going to boot that c term to the other side. So I'm going to subtract 7 to the other side. And I'm going to leave a space. And what I'm asking is, what do I need right here? What number do I need to make this into a perfect square? What number would that be? And there's a little trick to it. The trick is you take this b term, and when I say b term, I'm taking that b term, I'm dividing it by 2 and squaring it. So my b term here is negative 6. Negative 6, negative 3 squared is 9. Okay, 9 is the magic number that I want for this to factor perfectly. 9 is the magic number. So if I add 9 to this side, that means on the other side, now the other side already has negative 7, but I got to keep the sides balanced, right, with weight. If I add 9 pounds to the left-hand side of the weight, I got to add 9 pounds to the right-hand side to keep these weighted the same, right? Now I'm looking at x squared minus 6x plus 9, and I'm like, oh, yeah, this will factor real nice for me now. What does it factor into? Factors in 9, you're like, well, it's got to be 3 and 3, right? And it's either got to be plus plus or minus minus because it's positive 9. Well, it's a minus minus. And by the way, it'll be that b over 2 term right there. That's what it'll factor into. So it'll be x minus 3 quantity squared. That's what we wanted. We wanted this to be a perfect square. Now negative 7 plus 9 is 2. So we've got x minus 3 quantity squared. Now that we've completed the square, we've got our number on the other side. We can go ahead and square root both sides to finish this. So now we just use the square root method, add 3 to both sides. So I got 3 plus or minus root 2. Let me go ahead and make this a you try it problem if you want to. I know this one does factor, but go ahead and do it by completing the square. Hopefully you took your 84 over first, and now you're thinking to yourself, what do I need to add in here to make this a perfect square? The trick is to take that b term, divide it by 2, and square it. That's your magic number. So 4 squared is 16. So you're going to want to add 16 to this side. If you add 16 to that side, you got to add 16 to the other side. And then what do you know? This thing will factor perfectly into plus 4 plus 4. Over here, it looks like we got 100. So I got x plus 4 quantity squared. I got my perfect square. So now I can use my square root method on this. Square root both sides. So I got a plus or minus 10. I subtract 4. So I got x equals negative 4 plus or minus 10. Well, negative 4 plus 10 is 6. Negative 4 minus 10 is a negative 14. So there's our two answers to that one. Before we get into the quadratic formula, just to kind of let you know where this comes from, if you have ax squared plus bx plus c, if we go ahead, you know, a, b, and c, of course, being real numbers here, so I'm gonna find the formula that would solve that for any a, b, and c, right? If I go ahead and completed the square on this, I would have ax squared plus bx equals negative c. I would take an a out. I would then take that b over a, divide it by 2, so I'd take a half of it, so b over 2a, and I'd square it. That's the magic number that I need, b squared over 4a squared. And so I would give it a b squared over 4a squared. Well, in all reality, that's ab squared over 4a squared if I distribute that. That's ab squared over 4a squared, which is b squared over 4a. So the other side is a b squared over 4a to offset that, right? Then I would go ahead and factor this, and this will factor perfectly into x plus b over 2a. And so over here I've got b squared over 4a minus c. Now what I'm going to do is I'm going to get rid of the a, divide by a on both sides, so this whole thing by a, which is both of those terms. And let me come up here. It's supposed to erase. So I get x plus b over 2a quantity squared equals, now if I divide both of those by a, that'll be b squared over 4a squared minus c over a. Let me get a common denominator, so I'm going to give this a 4a and a 4a. And now I'm going to run the square root method. Square root of the top. Square root of 4a squared is 2a. Now let me subtract b over 2a on both sides. And there's our quadratic equation. That's where that comes from, was completing the square. And maybe you guys learned it in your Algebra 2 classes with the old x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And I'm sure you're thinking, please don't ever do that again to us. But that's one way that you can remember that, right? That's your quadratic formula. X equals negative b plus minus square root of b squared minus 4ac all over 2a. And I'm going to erase all this so we can do that problem. So with the quadratic formula, as long as I've got in this form ax squared plus bx plus c equals 0, let me go ahead and write ax squared plus bx plus c equals 0. So hopefully you notice my a is 1, the number in front, right, that 1. My b is a positive 4, my c is the positive 2. And then I'm just going to go ahead and write x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And then we're going to plug it in. My a is 1, my c is 2. This is all over 2 times a. And so we end up with negative 4 plus or minus the square root of 16 minus 8 all over 2. So we get negative 4 plus or minus the square root of 8 all over 2. Now we do need to simplify that square root of 8. I know the square root of 4 is 2. So 2 will go into both of those, right? Negative 4 over 2 is just a negative 2. 2 over 2 is just a positive 1 root 2. So we end up with negative 2 plus or minus the square root of 2. On the one down below that, hopefully you notice, oh, that's not equal to 0, right? So we got to get that one side equal to 0. I like my a to be positive, so I'm going to take this stuff over to the left-hand side. So I got 5x squared minus 5 plus 6x, except I got to write that in standard form. 5x squared plus 6x minus 5. So I can recognize my a, b, and c. My a here is 5. My b is a positive 6. My c is negative 5. And we're going to plug it in. X equals negative b plus or minus square root of b squared minus 4a times c all over 2 times a. Four and 34 gives you that 136. Square root of 4 is 2. And notice a 2 will come out of each of those, right? Like negative 6 is negative 3 times 2. There's a 2 right there. 10 is a 2 times 5. So it's got to go into both, right? Because that 10 is a common denominator. So I got negative 3 plus or minus the square root of 34 all over 5. Go ahead and make those last, both of those two as you try it problems. So go ahead, pause the video, try both of those. Now hopefully when you plug that in, you know your a is 4, your b is negative 1, your c is 2. Should end up with 1 plus or minus the square root of negative 31 all over 8. But we cannot take the square root of a negative number is the problem, right? We're working in the real numbers right now. We're not working in the complex or imaginary numbers. So right now we're just going to say that there's no real solution here. And we'll end it right there. Your next one you should have had x equals negative b plus or minus square root of b squared minus 4. A is 1, c is 11, 4ac all over 2 times a. So you end up with negative 9 plus or minus 81 minus 44. That'll be 37. And looks like that's as far as you can go on that. Negative 9 plus or minus the root 37 all over 2 is what you should have got for that try problem. Well, thanks so much for watching. Solving quadratic equations, taking notes. See you next time.